This is doubly committed VSD, and this parasternal short axis view. This is left atrium, this is right atrium, this is right ventricle outlet, and this is pulmonary valve, and this is aorta and aortic valve. You can see the VSD in this view is very close to pulmonary valve. That is why we call it doubly committed, because it is close to pulmonary valve. This is parasternal long axis view. If you make this view right ventricle inflow view, in that case what happens? The VSD disappears, indicating VSD is not perimembranous. Perimembranous VSD becomes more visible when right ventricle inlet view is being made. So that is the point to know. In parasternal long axis typical view, if you just make right ventricle inlet view, then VSD becomes better, more visible. In that means it is perimembranous. It becomes better on right ventricle outlet view. That means it is doubly committed VSD or outlet supracrustal VSD, you can say. That is a point to know. In parasternal long axis view, typical parasternal long axis view, if you simply angulate the probe towards tricuspid valve, then VSD becomes better, more visible, then it is perimembranous. If you make that view, that is angulating the probe towards pulmonary valve, that is right ventricle outlet view, then VSD becomes better, more visible. That means this is doubly committed VSD. That's the point. This is parasternal long axis view. This is left atrium, this is left ventricle, this is aorta, and in some frames it is right ventricle inlet view, right atrium, right ventricle visible in inlet view. You can see again VSD becomes better when it is simply slightly angulated towards pulmonary valve. You can see the pulmonary valve also in this view. This is the gradient across VSD, that is 69 millimeter of mercury. Here gradient is 65 millimeter. This is the location and VSD and size of VSD, 1.6 millimeter. Again you can see this is parasternal short axis view. This is left atrium, this is right atrium, this is right ventricle, and this is VSD. This is pulmonary valve. You see the pulmonary valve, and VSD is very close to pulmonary valve, almost close to pulmonary valve. This is left atrium, this is right atrium, this is subcostal view. This is aorta, this is IVC, this is subcostal transverse section. This is parasternal long axis view. This is left atrium, this is left ventricle, this is aorta, and flow is going into aorta. This is the location of VSD. This is left atrium, this is right atrium, this is right ventricle, this is aorta, this is pulmonary artery, pulmonary valve, and this is the VSD. VSD is both below aortic valve and below pulmonary valve, doubly committed VSD. Only important clinical finding is whenever this VSD is present, VSD needs closure, because this type of VSD does not get closed by a spontaneous mechanism, does not get closed by itself. So VSD needs management, and VSD is very commonly complicated by aortic valve prolapse or right ventricle outlet obstruction, because very close to right ventricle outlet portion and very close to pulmonary valve and aortic valve. Aortic valve is very important thing, so aortic valve is complicated in this case. You can see this anterior cusp is very close to this VSD, so anterior cusp of aortic valve is very commonly prolapse if this kind of VSD gets complicated. So that is the point. Whenever you get outlet supracrustal, or you can say doubly committed VSD, that VSD needs attention, that VSD needs closure. Surgical closure is a proper mechanism to close this type of VSD, and this type of VSD is very important. So perimeral VSD and this type of VSD are two different pores. One VSD is very close to pulmonary valve, then that is doubly committed. One VSD is very close to tricuspid valve, that is perimeral VSD. So perimeral VSD is likely to get closed by a spontaneous mechanism, spontaneously, because very close to tricuspid valve. Tricuspid valve is very redundant valve, extra portion. That extra portion is utilized to close the valve. That is the fact. So whenever you get outlet supracrystal, that is doubly committed valve, that is very important to know. Thank you.